In the diagram, circle P is congruent to circle Q, line segment FG is congruent to line segment JK, and the measure of arc JK equals 120 degrees. Find the measure of arc FG. Because line segment FG and line segment JK are congruent chords, the corresponding minor arcs are congruent by the congruent corresponding chords theorem. So in circle Q, you were given that the measure of arc JK equals 120 degrees. So the measure of arc FG equals the measure of arc JK. Thus, the measure of arc FG equals 120 degrees. Part A. Find KH. Looking at the diagram, notice that line segment JL is perpendicular to line segment KH, and line segment JL is a diameter. So by the perpendicular chord bisector theorem, line segment JL bisects line segment KH, and HN equals NK. So again, looking at the diagram, you were given NK equals 14. And because line segment JL bisects line segment KH, KH equals 2 times NK. So KH equals 2 times NK, which equals 2 times 14, which equals 28. Thus, KH equals 28. Part B. Find the measure of arc HLK. Line segment JL is perpendicular to line segment KH. So by the perpendicular chord bisector theorem, the measure of arc HJ equals the measure of arc JK. So substitute in the given information from the diagram, which gives us the quantity 2x minus 8 degrees equals the quantity 127 minus x degrees. Adding x to each side gives 3x minus 8 equals 127, and adding 8 to each side gives 3x equals 135. Then dividing by 3 on each side gives x equals 45. Now substitute 45 back into the measure of arc HJ, which gives us the measure of arc HJ equals the quantity 2 times 45 minus 8 degrees. Simplifying gives us the measure of arc HJ equals the quantity 90 minus 8 degrees. So the measure of arc HJ equals 82 degrees. Then looking at your diagram, you want to find the measure of arc HLK. So the measure of this arc will be equal to 360 degrees minus the measure of the arc HJK. And notice that the measure of arc HJK will be equal to 2 times the measure of arc HJ. So the measure of arc HLK equals 360 degrees minus 2 times the measure of arc HJ. Substituting in the value for the measure of arc HJ gives us the measure of arc HLK equals 360 degrees minus 164 degrees. Simplifying gives us the measure of arc HLK equals 196 degrees. A telephone company plans to install a cell tower that is the same distance from the centers of 3 towns, labeled P, Q, and R. Where should the cell tower be placed? Begin by drawing line segments to connect the points P, Q, and R. So you have line segment PQ and line segment QR. Then draw the perpendicular bisector of line segment PQ and the perpendicular bisector of line segment QR. So then by the perpendicular chord bisector converse, these lie on diameters of the circle containing points P, Q, and R. Find the point where the perpendicular bisectors intersect. This is the center of the circle, which is equidistant from points P, Q, and R. So the tower should be placed at point T, where the perpendicular bisectors of line segment PQ and line segment QR intersect. In the diagram, EP equals EQ equals 12, CD equals 5x plus 7, and AB equals 7x minus 3. Find the radius of circle E. So line segment CE is a radius of circle E. Let R represent the length of line segment CE. Then by the equidistant chords theorem, line segment AB is congruent to line segment CD. Because both line segments EQ and line segments EP are perpendicular to the chords and have the same length. AB equals CD. Substituting in the given information gives 7x minus 3 equals 5x plus 7. Then subtracting 5x from each side gives 2x minus 3 equals 7. Then adding 3 to each side gives 2x equals 10. Dividing by 2 on each side gives x equals 5. Looking at your diagram, notice that you have a right triangle, triangle CEQ. So in order to find the radius of circle E, you need to find the length of line segment CQ in order to use the Pythagorean theorem. Because Because line segment EQ is perpendicular to line segment CQ, CQ equals 1/2 times CD. Because CD equals 5x plus 7, CQ equals 1/2 times the quantity 5x plus 7. Substituting 5 for x gives CQ equals 1/2 times the quantity 5 times 5 plus 7. So CQ equals 1/2 times 32. So CQ equals 16. Then use the Pythagorean theorem to find the radius of circle E. So r squared equals 12 squared plus 16 squared. Simplifying gives r squared equals 144 plus 256. Adding 144 and 256 gives r squared equals 400. Then take the positive square root of each side to get r equals 20. Thus the radius of circle E is 20 units.